Next, we have the Moki's law number 2 on bond pricing. In Moki's law number 1 on bond pricing, we have discussed the relationship between bond price and YTM. What do we discuss in law number 2? In Moki's law number 2 on bond pricing, we will discuss the changes of bond price and bonds maturity. Let's look at this picture. This is the bonds maturity from 5 years to 10 years, 15 years, 20 years, and 30 years. The bond maturity in terms of years. Suppose we have a bond now, its face value is 100, coupon rate is 7%, annual payment of term dividends is 2, which is the redemption. The maturity is 8 years, YTM 6%. 8 years is here, which is the anchor point now. And it changes this way, we increase the maturity, and change this way, we decrease the maturity. This graph demonstrates when we increase or decrease the number of years in terms of maturity, how the changes bond of prices performs. Okay. So this is the zero part of the change of bond price. Suppose the bond price is P and the changes of bond price is delta P equals to P2 minus P1. This is the 0 points. When the changes of bond price is above the 0 lines, it means bond price increase, right? And when the changes of bond price below 0 lines, it means bond price decrease, right? Okay. Then let's find out that when we have longer period of maturity, bond price increase. When we have less maturities, bond price decrease. Or in other words, when we have longer time of maturities, the changes of bond price increase. And we have shorter period of maturity, that the change of bond price decrease. We can also say this way. So from this, we can find out the relationship between bond price and its maturity. We can summarize as this. When maturity of bond price, when maturity of a bond increases, gets longer, bond price goes up, or the change of bond price goes up. This is a change of bond price. This curve means goes up. Not only the bond price goes up, but also the change of bond price goes up as well. When we have a short term of maturities, bond price goes down, as well as the change of bond price goes down as well. If we have learned calculus, we can see that the change of bond price is something like this, right? The change of bond price is a partial difference. Partial difference. Remember, this is the 0 line. And this is very useful in bond trading as well. We know that the difference of price between long-term bond and short-term bonds. If all the other conditions are the same, we can say that long-term bond usually have higher price, while short-term bonds usually have a lower price, right? And we can find out as a bond is gradually moving to its maturity. That means the bond's maturity is getting shorter and shorter. That is changing this way. If all the other conditions remains unchanged, the bond's price should go down gradually. I repeat, if all the other conditions remains unchanged, when the bond goes to its maturity gradually, its price should goes down gradually, just like this curve. This helps us understand the change of bond price when the bond is going to its maturity, right? So we can summarize what we find in the figure just now in this way. If all else remains constant, the changes of bond price are positively correlated with the changes of maturity. That means if the changes of maturity is positive, the changes of bond price is positive. If this is negative, this is negative. They have the same signs. Or the changes of long-term bond price is higher than those of short-term bonds. Okay. In order to understand this, let's look back. Okay. This is a long-term bonds. Long-term bonds. And this is the changes within 5 years. And this is the changes in 5 years as well. So this is the demonstration of this conclusion. Or we have another word. Long-term bonds have higher price risks than short-term ones. So how do we understand this? Because the long-term bonds, we have higher changes. When we have changes of maturities, for long-term bonds, they have higher changes in terms of their prices. So these 2 points are difficult for us to learn or for us to understand. But we can remember this one. That's good enough. So let's look at the Python commands. Then we copy this command into Jupyter Notebook. Then we can see the situation. Okay, let's demonstrate this command. Yeah, it's the same. This is Moki's law on bond pricing. It discusses the relationship between bond price changes and time to maturity. This is time to maturity. And this is bond price changes. It is in the up curve trend and upward trend. So this is the zero line. This is the zero line. Okay. And we have the anchor point is here. So for a bond with this par value 100, coupon rate 7%, redemption 2 times, maturity 8 years, YTM 6%. Okay, it's here. When we have longer maturities, the bond price will increase, and the change of bond price is positive as well. When we have a short term for maturities, bond price will go down. That means we will have a negative bond price change here. And this way, the bond price change is less than 0. So bond price goes up, bond price goes down. This is what Moki's law number 2 tells us. Do we have any questions? If not, we can change some of the bond parameters and let's try to call someone to explain. Say, for example, okay, let's change YTM from 6% to 8%. Let's change the redemption from 2 times a year to 4 times a year. What else can we change? Okay, we can change the face value, for example, from 100 to 1000. Actually, I believe it doesn't matter because the bond price is a percentage over the face value. Now we can change the anchor point now from 8 years to suppose 5 years. Let's see what will happen to the curve. Now we have the anchor points of maturity is 5 years here. It's 5 years here. And this is the zero line here. The zero line here. Now I'll try to call someone help to explain. What about Liu Zhe?
Okay, sir. Can you hear me clearly?
Yes, I can hear you clearly.
The bond price changed the downward.
Downward. Yeah.
Yeah.
What do you mean by downward here? Why is downward? This is pretty interesting, right? When we have a longer period of maturities, delta P is less than 0, right?
Yeah.
Yeah. And when we have a shorter period of maturities, delta P is bigger than 0, right?
Yeah.
So what happens here compared to the situation, to the case study we have seen just now? So previously our curve is an upward one. You can see previously this is our curve, right? This is our curve. Yeah. It's an upward.
Yeah. Upward.
Yeah, and we have the relationship between coupon rate and YTM is lower than coupon rate. And for this picture, we have another situation. YTM is higher than coupon rate. And then the curve in another trend from upward trend to a downward trend. So from this, what can you find out? Now it's downward now.
Yeah.
So situation changed, right? Because we changed the relationship between coupon rate and YTM. So if YTM is bigger than coupon rate, what happened? It's downward, right?
It's downward, yeah.
If YTM is less than coupon rate, what happened? It's upward. It's upward. Now, can you imagine if YTM equals to coupon rate, what will happen?
Just the don't change.
Don't change. It means flat, right?
Flat. Yeah.
Well, this is just a hypothesis for now. We need to prove them. So let's see what will happen. Let's change the command. This time we said what? YTM equals to the coupon rate. We both set to 8%. Then let's see what will happen. Okay, now it's flat, right?
Yeah.
It's flat. So this is pretty interesting, right? It's flat.
Yeah.
Now we can have a broader view on Moki's law number 2. If YTM is bigger than coupon rate, the curve will be a downward trend. And YTM, if is less than coupon rate, it will be an upward trend. And YTM, if equals to coupon rate, it will be a flat situation like this, a flat one. Are we right?
Yeah.
Yeah. Okay, thank you, Liu Zhe. Now, let's have a summary on Moki's law number 2. In Moki's law number 2, we discusses the change of bond price with its maturity. Versus its time to maturity. We have 3 situations. If YTM or market interest rate is bigger than coupon rate, it's a downward trend. That means if we have a longer time to maturity, and the bond price will goes lower. Okay, bond price goes lower, and the changes of bond price get smaller. This is the first scenario. The second scenario, if we have YTM or market interest rate less than coupon rate, it will be an upward trend. If we have a longer time to maturity, the bond price will get higher, and the changes of bond price will be higher as well. Okay, this means the change of bond price will be minus. This means the changes of bond price will be positive. This is negative, positive. This is the second scenario. The third scenario, if we have YTM equals to coupon rate, it will be a flat trend. That means whatever the time to maturity changes, bond price does not change, right? So these are the 3 scenarios when we talk about Moki's law number 2, the relationship between change of bond price and its time to maturity. Yeah, we have done this before. Now, let's have a new topic. We talk about Moki's law number 3 on bond pricing. Moki's law number 3 on bond pricing discusses the relationship between bond price change risk versus its maturity. So the previous law, law number 2, we talk about bond price change versus its maturity. But law number 3, we discuss in the further situation, which is the risk of bond price change versus its time to maturity. Let's look at these relationships. And we have the picture like this. It's the maturity in terms of number of years. Okay, it's time to maturity 1 year, 2 years, 3 years, until 16 years. And here we have 2 vertical axes. This one we use to describe bond price, okay, from 102 to 110. And this is the blue solid line, bond price. The second vertical axis we use to describe the speed of bond price changes. The speed of bond price changes can be understood as the risk of bond price changes. How do we understand this? This means if the speed of bond price changes is fast, that means the bond price may change in a faster pace. If the speed of bond price change is small, that means the bond price changes at a smaller pace, at a bigger pace or a smaller pace. Of course, if the bond price changes at a bigger pace, its risk of bond price change is definitely high, right? And vice versa. So we can use the speed of bond price changes to describe the risk of bond price change. So how can we understand the speed of bond price changes from the perspective of calculus? Suppose P is the bond price, and the bond price change is delta P, right? Or we describe this. And the speed of bond price change could be delta P, or we describe that as this. Yeah. This is the perspective from calculus. However, this course does not focus on calculus, so don't worry about this. And then let's find out. As we find out as the time to maturity increases, the bond price increases, right? And in the meantime, as the time to maturity increases, the speed of bond price decreases. Okay? I repeat. As the time to maturity increases, bond price increases. However, the speed of bond price decreases. Okay. These conclusions is applicable in the following situations. We have the bond face value 100, coupon rate 7%, redemption 2 times a year, maturity 8 years. Okay, this is the anchor point we have here. And we have YTM 6%. So if we still remember the conclusions in Moki's law number 2, we are aware that the curve, the trend also may be related to the relationship between coupon rate and YTM. The situation here is coupon rate is bigger than YTM. What about the situations if coupon rate is less than YTM? We can do a practice on that. Let's look at the command. Okay, we have here, we copy the command and paste in Jupyter Notebook. Here we have, this is the YTM. This is the time to maturity in terms of number of years. And this is the coupon rate. This is the face value. And this is the redemption. Means number of dividends a year. Okay. Let's copy it into Jupyter Notebook. First, let's replay the case. Okay, this is the same situation as we have seen in the slides. Remember, the situation here is we have the situation. What? The situation is YTM is less than coupon rate. Less than coupon rate. Here we have the YTM 6%, and we have the coupon rate 7%. This is the situation. If we reverse the order of the relationship between YTM and coupon rate, what do you think? Let me try to call someone. You can just make a prediction on that. Okay, let's see. Let me find out the person. Zhou Siyuan. Can you do an imagination on this? Just a guess. Then we will prove your guess.
Hi, Professor. Can you hear me?
Yes, I can hear you, but could you speak a bit loudly?
Okay. Because the coupon rate is higher than the YTM,
So we will have a new situation. Here, this is the YTM. This is the coupon rate. Now, the situation now is YTM is less than coupon rate. What will happen if YTM is bigger than coupon rate? Suppose we change this to 5%. What do you think this picture will change?
I think their cover trend will become into down low.
First, what do you think about the trend of bond price? Here in this picture, the trend of bond price is upward. However, in the new picture, what do you think the trend of the bond price?
The bond price trend will become downward.
You think it's downward, right? Then, what do you think about the trend of these orange dot lines? In this picture, it is downward. What do you think in the new picture?
Their trend will become upward.
Upward. Okay. So in your imagination, in the new scenario, the trend will be reversed, right?
Yeah.
Okay. Then let's look at the results. Wow. This is the situation in the new picture. I think you are all right. So thank you, Sian.
Thank you, Professor.
Okay. Now, this is the new situation. In the new situation, we have a different situation. We have coupon rate is 5%, while YTM is 6%. In this scenario, YTM is bigger than the coupon rate. It's bigger than the coupon rate. And in the new picture, when we have longer time to maturity, the bond price goes down in the downward trend. And the bond price change speed, or it is the risk of bond price change, is in an upward trend. Upward trend. This is pretty interesting. That reveals a very important rule in bond pricing. Okay. The rule is the relationship between YTM and coupon rate is a critical factor in bond pricing models, right? The relationship between YTM and coupon rate. So here we can have YTM refers to market interest rate. Okay. When YTM bigger than coupon rate and when YTM less than coupon rate, the bond pricing models may behave in different trends. Most of the time, it will be a reverse trend. Okay, so this is very important for us to understand Moki's law. Do we have questions up to now? If done, let's move. Our new topic is about Moki's law number 4 on bond pricing. We have learned Moki's law number 1, 2, 3 on bond pricing. And what will we learn from Moki's law number 4? This is the question in this topic. Well, Moki's law number 4 seems a little bit complicated, right? The fourth law discusses the relationship between bond price change as well as YTM change. Okay. And YTM change means delta YTM, right? And bond price change means delta P, suppose we have. Huh? Okay, let's look at this picture. Here we have a bond. Suppose the face value is 100, coupon rate is 7%, redemption 2 times a year, maturity 8 years to maturity, and YTM 6%. Here we have the situation YTM is less than coupon rate. It's less than coupon rate. Okay, remember this condition. And we have the change of bond price here. Let's look at the blue solid line. The blue solid line is the bond price falls by rising YTM. How do we understand this? Here we have the YTM and its changes. We have the anchor points here, 6% YTM. And this point, we increase YTM by 50 base points, up to 300 base points. That means this direction, we have higher and higher YTM, means YTM increases. While this direction, we decrease YTM by 50 BP, 100 BP, until 300 BP respectively. And these times we mean that YTM decreases. This direction, that means YTM increases. With YTM increases, the change of bond price is the solid blue lines. Here we have the zero lines. This is below zero lines. That means as we increase YTM, suppose all else conditions remains unchanged, the change of bond price, delta P, will be less than zero. That means the bond price decreases, right? If we have less and less YTM this direction, we find that the red part is the bond price rises by falling YTM. This one, YTM is falling. So this is our change of a bond price, delta P. Here is above the zero line, which is bigger than zero. That means our bond price is increasing, right? Now, Moki's law number 4 expects to compare if we change the same scale of YTM, the decreased part and the increased part, their size of their absolute value. Absolute value. So, in order to compare the absolute value of the two situations, we have a special tip on that. First, in order to compare this, we upturn this line here with the same angle. Then we turn the line in this way to the dot blue lines here, dot blue lines, and in the same angle. In this way, we can compare if we change same BP of YTM, one direction increase, another direction decrease, what will be the difference on the changes of bond prices? We find that they are different. That means, if we increase YTM and decrease YTM by the same, for example, delta small r minus small r, and cause different scale of bond price change. This is delta P plus, this is delta P minus. They are equal to each other. However, they are not equal to each other. So this phenomenon we call symmetric effect. A symmetric effect. A symmetric effect means delta P minus and delta P plus not equal to each other. Although we have all other things remain unchanged, and we change the same scale of YTM to two directions, one increase, another decrease, and cause a symmetric change on bond price. Okay, this is a little bit difficult for us to understand for the first time. If you have any questions, welcome you propose your question in our course WeChat group. Okay. Next, let's look at the Python script to draw this picture. It's like this. This one. Let's do it. Replay the case first. Now we find the situation which is the same. And please remember, this is the scenario where YTM is less than coupon rate. Right? Here YTM is 6%, while coupon rate is 7%. So 6% is less than 7%. Next, we'll try to do a test I have never done before. So I don't know the result. Let's try it. Probably we can find something new. Then we can write a new article on this. Okay, so suppose we change the coupon rate to 5%. And in this way, we have another situation. Here we have YTM here is 6%, and we have coupon rate. Here we have 5%. What happens? What happened? Let me try to call someone to explain. What about FENG Mengchu? Mengchu, are you there? Or are you waiting to explain? The scenario here is YTM is bigger than coupon rate.
Hello, Professor.
Yeah, I can hear you, but your voice sounds very small. Would you please to speak louder or speak closer to your microphone?
Okay, I will try.
Okay, thank you.
Okay, thank you. Okay.
So, what are your comments on this new picture compared to the previous one?
Well, I think in this picture, the YTM is larger than the coupon rate.
YTM
And
still 6% here, right?
yeah. Let me see.
The new situation is YTM is bigger than coupon rate because YTM here is 6%, while coupon rate is 5%. Right?
Yeah.
So we can start from the blue solid line. So what is the blue solid line here? It is the decrease in bond price due to increasing YTM, right?
Yeah.
So it is the delta P. And here we have increasing YTM. So here the delta P is caused by the increasing YTM.
Yeah.
And we can see this is the zero line. This is the zero line. And it is below zero line, right?
Zero line. Yeah.
That means
it's decreasing.
Delta P is less than zero. So
Yeah.
here we have delta P, right? And bond price is decreasing, right? Because delta P is less than zero. So we will have decreasing bond price, right?
Yeah.
So next, let's look at the solid red line here. The solid red line represents the increase in bond price due to decreasing YTM. So this way, we have a decreasing YTM, means YTM gets smaller and smaller. Here we decrease YTM by 50 BP until we decrease YTM by 300 BP, right?
Yes.
And this is the zero line. This time we find the zero line is above. Yeah. So the delta P caused by decreasing YTM now is bigger than zero.
Zero.
And what does it mean to bond price? Increase or decrease?
Increase.
Increase. You are right. It's increase. So the situation is the opposite way compared to this part, right?
Yeah.
And next, we expect to compare the absolute value happen to bound price if we increase or decrease, suppose 200 BP. If we increase 200 BP to YTM, the absolute value of bound price change is here, right?
Yeah.
So this is delta P minus. However, if we decrease 200 BP to YTM, the increased part of bound price is this way. So this is delta P minus, plus. Now, what do you think about the relationship between delta P plus and delta P minus? Which one is bigger in terms of their absolute value?
I think delta P minus is smaller.
Yes, delta P minus is smaller and delta P plus is bigger. So the delta P minus and delta P plus, they are in a strange relationship. We call this asymmetric. Asymmetric, right? Yes, they are symmetric because one is bigger, another is smaller. Previously, we may think this should be the same because we change the same size of YTM, but we cause the different changes on bound price. So this means a symmetric relationship. So the Moki's law, number 4, is called a symmetric law on bound pricing. Thank you very much.
Okay, thank you, Professor.
Yeah. Now, from this, we can quickly realize, okay, if all L conditions remains unchanged, suppose we have two situations, YTM increases and YTM decreases, what do you think about the risk caused to bound price? Okay, we have two situations. Let me explain. Situation 1, we have YTM change, YTM increase. And situation 2, we have YTM decrease. So what do you think about the risk to bound price changes under these two circumstances? We can find out that compared to decreased YTM, an increased YTM caused less risky situations, a situation which is less risky because the order of magnitude change to bound price is smaller. It's smaller, right? If we have YTM decreased, it causes bigger change of on-bound price change, right? It causes bigger risk on bound price changes. So in this way, we call the risk is bigger. The risk is bigger. Now you have a very strange conclusions compared to our common sense before we learned this law. When we have, suppose we have all the other conditions remain same in market, if we see market interest rate increase, and if we see market interest rate decrease, what do you think that the risk to bound price caused by the changes, YTM or market interest rate? If you haven't learned this session, you may think, wow, market interest rate increase may cause a bigger risk to bound price, right? However, the reality is, compared to market rate decrease, market rate increase, the situation with market rate increases caused less risky to bound price changes. So this is very different from our common sense. And this is also the magic of this law. Do we have any questions on this? I believe this is pretty hard for us to understand, especially for people first time to learn something about bound. If we don't, let's have a break, a 10 minutes break.